This topic we're talking about automobile 48 car battery systems. For the car battery evolution, this history like this. Since from 1918, it starts from 66-volt car battery. It supplied the car lighting and starter engines. Evolved to 1950, the car battery voltage became 12 volts. And this maintained 60 years until 2011. Not only 12-volt car battery, it included with the Germany have a criteria standard LV148 integrated with 48 car batteries. Even last year, the Tesla insists it will use only the 48 car batteries. The 12-volt car battery is supplied the loads like infotainment and the car lighting, brake system, and body electrons. 48 car battery, its loads includes of EPS, electric heating, water pump, and some comfortable modules like air suspension and air conditions. The 48 car battery system, it can save the wire weight to reduce the power loss. Like an example, if loss the power dissipation is 600 watts, when we use 12-volt car batteries, the load current will need 50 ampere. When we change to 48 car battery, the load current is only 12.5 ampere. Based on this, the wire cross-section area of the 12-volt car battery, it is 10 millimeter square. When we choose the 48 car battery, it is only 1.5 millimeter square. There is 80 smaller size. Based on this, we have two benefits. The length per length of the weight in 12-volt car battery. Per meter, the weight is 108 grams. When we use 48 car battery, it is only per meter 17 grams. There is 80% weight reduction. And per length, the power dissipation in 12-volt car battery per meter, his power dissipation is 4.45 watts. When we're using 48 car batteries, it is per meter power dissipation is 1.88 watts. There is half loss reductions. So in 48 car battery certification, there are two. One is LV148, comes from Germany. Another is ISO 21780. There is a criteria of this 48 car battery. When it's up to 60 volt, it needs to do protection nest. In ISO 2178T, this criteria is test pulse. The most serious of the test pulse is a test 03. This is also called short turnover voltage. It applied the peak voltage is 70 volts and the time duration is 40 milliseconds. In LV148 criteria, here's the test voltage, peak voltage 70 volt. And the time duration is 40 milliseconds. So the IC design when it's over 70 volts, normally it can sustain 85 volts. So the more bigger is the automobile power supplier Delphi. It has 48 mid-hybrid solutions like this. There is a 48 car battery and this is 12-volt car batteries. The 48 car battery can convert the voltage to driver, the ISG and the BSG motors. And the 48 car battery can use the DC-DC converter to buck the voltage and supply energy to the 12-volt car batteries. The bar diagram will be here. The 12-volt car battery supply the 12-volt loads by the 12-volt protections, The 48 car battery supply the 48 volt loads and use also supply turbo for the motor driver to drive the VSG and ISG motors. So we'll see where is the discrete and maybe some of TSC opportunities. The first is the turbo protections. Input the car battery sections. There is a D1. It can use the TBS SMB package, working voltage 24 bidirectionals. This can shun the transient surge like ISO 7637-2, the +1 and the +2A. As for the ideal diode controller to control the MOSFET, this can use 60 volts low RDS(on) like these parameters. This can serve as reverse polarity functions. Another one is the motor drivers. The motor driver uses a 3-phase switch to control the VSG and ISG motors. This circuit is 1-phase examples. The 15 kHz 3-phase switch can use the MOSFET Q1, 100 volt and a low RDS(on), like these TSC solution parameters. Another one is D1. This can use the Schottky 100 volt 1 ampere SOD123 package. This could speed up MOSFET turn-off transitions. As for protection portions, the D1, this can use the TBS SMA package, 14 working voltages. This can connect the MOSFET gate and the source to prevent the MOSFET gate over voltage transients. Another one is the D2. This can use the Schottky diode 101 ampere, can serve as RCD diode to clamp the passive reading across the MOSFET drain to source. Another one is a 40 buck to turbo DC-DC portions. This circuit is a 48 volt circuit breakers. In the input car battery 48 volt, this portion can use a D1 TBS SMA package 78 working voltage bidirectional for the ball level transient protections. And the Q1, Q2, Q3s, the circuit breaker is a back-to-back low RDS(on). This can use 100 volt and a low RDS(on) like these parameters, can serve as the circuit breakers. As the buck circuit, buck the voltage from 48 volt to 12 volts. There is the D1, the Schottky diode, 100 volt 1 ampere can serve as a bootstrap diode. In Q1, Q2, synchronous switching MOSFET is a 100 volt low RDS(on) like these parameters. And the next is the 12 volt circuit breakers. In the 12 volt car battery input section, there is a D1 TBS SMA packages, 24 volt working voltage bidirectionals. This is input transient protections usage. As a Q1, Q2, Q3, Q4, Q5, Q6, the back-to-back low RDS(on) MOSFET can use 40 volt, and the parameter like these can serve as circuit breakers. As the communication portions of the CAN bus, the micron signal, the CAN TS and RS. It can isolate first and transfer signal to the CAN transceivers bus to become the CAN high and CAN low signals. There is an ESD protection diode, 48 volt working voltage like these TSC parameters, for the 125 kbit per second speed transceiver protections. So there are many suppliers have their own design circuit. Of course, we still have other components opportunity, like the MOSFET, the perfect MOS, 100 volt MOSFET. We will have next year January 80 volt MOSFET, it will be the March next year. And what we have now is 40 volt MOSFET. And Schottky diode 100 volt, 60 volt, 48 volt package in SMPC 4.6U packages we have available already. And some small signal diode like Zener diode can stabilize the micron pin voltages. And some small signal Schottky is application can clamp the voltages, and transistor and the small signal MOSFET is application is the signal switch functions. They all will be released next year, September. This year, September. And some, if the supplier they don't use the PMIC IC, they will use discrete. So there is a LDO opportunities. What we will have in this year is a low quiescent current series. And for the TBS, what we have now is the super clamper TBS series. We have the DO218 already, and we will have this year is SMB and SMC package. This can apply in a 48 volt car battery when we connect two diodes in series to offer a low clamping voltage purpose. And some big power bidirectional in SMC and 400 watts in SOD123. And we have the ESD CAN bus in SOD23 already. What we will have this year is the DFN patches.